Hi everyone. Today we're going to look at the solving of simultaneous equations using substitution method. So in the previous video, I've shown you how to perform the solving using elimination method. Now today we're going to look at substitution method. They are both valid methods, and the elimination and the substitution method, they both give you the same solution of x and y if you're solving simultaneous equation. All right, so we're going to explore this method today, and we're going to see how this is done. All right, so let's look at example 1. We have y minus 3x equals to negative 10 and x plus y equals to negative 2. So what we usually want to do with the use of substitution method is that we want to rearrange one of the equations such that either y or either x is the subject. All right, and once we have that, we are going to substitute it to the other equations. All right, I'm going to show you how this is done. So I'm going to first assign this as equation 1, and I'm going to assign this as equation 2. So once I have that, I am going to rearrange equation 1. So I would say therefore y is equals to 3x minus 10. And I call this equation 3. So I rearrange equation 1, and the main reason I did that is because I want to make y the subject, so it allows me to substitute to equation 2 efficiently to solve for x. Right? So now I'm going to have equation 3. I am going to substitute that into equation 2. All right, so it's going to look something like this. X plus bracket 3x minus 10 equals to negative 2. Now notice that my y is being replaced with 3x plus 10 right here. Yeah, so that is why it's called substitution, because you're replacing one of the variable. All right, so from there, I'm going to expand out the bracket and solve for x. So 4x minus 10 equals to negative 2. So 4x equals to 8, and x equals to 2. Now, this should help me to find my y. So I'm going to substitute into equation 3. So y equals to 3 times of 2 minus 10. So y will be equals to 6 minus 10, so minus 4. So therefore, we're going to say the solution is 2, negative 4. So that will be the intersection between these two linear equations. All right? Yeah, I'm going to shift it right here a bit. Okay, so that will be the conclusion of example 1. Now we're going to look at example 2, and we're going to see how we can use substitution again. All right, so example 2. Now, I look at equation 1 and I look at equation 2. It seems to me that it is easier for me to rearrange equation 1. And this time around, I'm going to make x a subject. All right, so x would be equals to 11 minus 2y. So that would be equation 3 for me, which I rearrange it from 1. Now, that being done, I'm going to substitute equation 3 into equation 2. All right, so you'll notice that I will have 4y minus, and I'm going to put a bracket. It's very important to put a bracket because especially with the negative, it multiplies through the bracket. Yeah. So I'm going to replace it with 11 minus 2y, and that entire thing is equals to negative 2. So we're going to expand out the bracket. Make sure you do it carefully. The brackets are very useful to help you to visualize the multiplication of the negative into that bracket itself. So 4y minus 11 plus 2y, and that is negative 2. Simplify it. So 6y equals to 11 minus 2. That would be 9. That would be 9. And from there, y will be equals to 9 over 6. And we can simplify that to be 3 over 2. All right? All right, so from here, we are going to substitute that into equation 3 to solve for x. So we say x will be equals to 11 minus 2 times of 3 over 2. 3 over 2 is like 1.5, right? Let's write it that way. So 11 minus 3, and x will be 8. So therefore, the final answer would be 8, 1.5. So that will be the intersection between the two equations. So this will be the two examples for solving of simultaneous equation using substitution method, and I hope this is a good recap of this skill. All right, I'll see you in the next tutorial. Cheers.